5th grade. We are going to do problem solving, compare volumes. Essential question, how can you use the strategy make a table to compare different rectangular prisms with the same volume? Let's unlock this problem. This is standard 5 MDC 5B. Adam has 50 1-inch cubes, 50 of them. The cubes measure 1 inch on each edge. Adam wonders how many rectangular prisms, each with a different size base, that he could make with all of the 1-inch cubes. Use a graphic organizer below to help you solve the problem. Okay, let's read the problem. What do you need to find? I need to find rectangular prisms right here, each with a different size base, that have a volume of 50 1-inch cubes. 50 cube inches. What information do I need to use? I can use the formula volume equals length times width times height. Or I can use volume equals B, which is the base on its own, times height. But you know, I'm sure you're all going to use that. And the factors of 50. So we're using the factors of 50 because that's what it says too. I will use the formula and the factors of 50 in a table. That's what it told us to do. That shows all of the possible combinations and dimensions with a volume of 50 cubic inches without repeating the dimensions of the bases. All right, shouldn't be too hard. Well, let's look at the rhythm here. 1 times 1, 1 times 2, 1 times 5, 1 times 10, 1 times 25, 1 times 50. Height 50, 25, 10, 5. So they're using the height here and the base is here, already done for you. So what they did was 1 times 1 times 50 equals 50. And you see the pattern going, and the pattern going, and the pattern going, the pattern going, and the pattern going like that. 1 times 50 times 1 is 50, and things like that. So we're going to carry on and we're going to go 2 times 5. Let's go all the way down. 2 times 25. Oops. 5 times 5. 5 times 10. Over here, it's going to be 5, 1, 2, 1. I'm sure you're going to use something different for yourselves. 2 times 5, 2 times 25, 5 times 5, 5 times 10. So you can use your own, of course, on that part, but still got to use cubes to make 50. We're trying to make 50. So you can use anything, but the point is we're trying to make 50. Whoops. So then I'm going to put here times 5 times 1 times 2 and times 1. Because we're doing different ones, but coming up with the same volume. So 2 times 5 is 10, times 5 is 50. 2 times 25 is 50, times 1 is 50. 5 times 5 is 25, times 2 is 50. 5 times 10 is 50, times 1 is 50. So the cubic one, because that's the volume that we're trying to make. But we're just using different ways to try and find it. That's basically in a nutshell. All right? And I'm not going to worry about evaluate. What else can you need to do to solve the problem? I need to use the table to count the number of rectangles. We don't have to do that. You can, I'm not worry about that. Just want to make sure that you got this set. Okay. Mrs. Wilton is planning a rectangular flower box for her front window. She wants the flower box to hold exactly 16 cubic feet of soil. Wow. How many different flower boxes, all with whole number dimensions and different size bases, will hold exactly 16 cubic of soil? Okay. Let's see what we got. What do I need to find? I need to find the different, I'm going to shorten this, different rectangular flower boxes, each with different bases that holds exactly 16 cubic feet of soil. What information do I need to use? I need to use the formula. Formula. Spell formula wrong. Formula of volume, and that is volume equals length times width times height, or volume equals B times H. How will I use the information? I will use the volume formula to find all factors. I will use volume formula to find all factors of 16 cubic feet. Hands are getting tired, guys. So let's go ahead and do this, and we're going to make a table. If you pause it, I will make the table quickly. Okay, so I drew this for you real fast so that you can understand. So what they want is all factors of 16, and that will bring you to actually solve what the volumes are in the end. So if we're doing all factors, let's start off with 1 times 1. 1 times 1 is 16. Then we've got 1 times 2 equals 8. These are all factors of 16. Then we've got 1 times 4. Let's go from 4. And 1 times 8. And so on. Pause it, and I'll just finish it off. Okay, so basically these are all the factors. 1 times 1 times 16. 1, 2 is 2 times 8 is 16. 1 times 4 is 16. 1 times 8 times 2 is 16. 1 times 6 times 1 is 16. 2 times 4 times 4 is 16. And you see that I put the volume and the formula. You can see that right there. 4 times 1 is 16. And that's basically in a nutshell. So let's just do one more answer, one more question. How many flower boxes with different bases will hold exactly 16 cubic feet of soil using whole numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. And that will be 9 flower boxes. And I hope that will help you out with your work this week. Thank you, 5th grade.